We're team number 11, and in this project, in comprehensive graphing, we're going to show how to understand a graph with derivatives and how to infer its function. So first, an absolute maximum or minimum are the largest or smallest values that the function will ever take on the domain that we are working on. A relative maximum or minimum is different. It is for that point to be a maximum or minimum in some weird interval of x's around. A continuous function may have a maximum at a single point or at a number of points. You can relate this comprehensive method to analyze functions of real-world matter of problem, for example, if we want to find the maximum height, or in the contrary, the minimum height of a function or of anything else. Other applications are, for example, in roller coasters, electrical engineering, molecular modeling, and also in economics.
Okay, so we got the equation f of x equals x at the power of 4 minus 4 times x squared. The domain of our equation is x equals minus infinity to infinity because it's a linear equation. It has no restrictions, and to get the x-intercept, we equal our equation to 0. Then we get the common factor that was x squared, and then we solve the parentheses that gave us x plus 2 times x minus 2 equals 0. And with this we get the x-intercept that was x minus 2 and x2, and we plug them in points and gave us a 0, 0, b minus 2, 0, and c 2, 0. So to get our y-intercept, we put 0 instead of x in our equation, and it gave us f of 0 equals 0 because the other thing was 0. So our y-intercept is d 0, 0.
So to find there is symmetry, we use this function x is equal to f of x, which means there is even symmetry in the function. And also we know there can't be odd because the exponents are even, so it has to be even symmetry. And when we analyze it, we also found that there is no horizontal or vertical asymptotes.
So our first derivative gave us f prime of x equals 4 times x cubic minus a times x, and this was our first derivative. And then to get the ID test, we equal our first derivative to 0. Then we take the common factor, and it gave us 4x times x squared minus 2 equals 0. And then we complete the square, and gave us of answer x equals 0, x square root of 2, and x negative square root of 2. That was from this one, and the 0 from the second. And these three answers are critical numbers equal our critical points.
In here we will plug a value from each region into the derivative to see if the result is positive or negative. After we plugged the values to see if the result was positive or negative, and we got intervals from our derivative and found a value that fitted in each interval and substituted it in the first derivative and analyzed it if it was positive increasing or negative decreasing. To get the maximum and minimum points, we got the factors of the first derivative and then we completed the square. In the concavity test, we got a value for the intervals and substituted them in the second derivative and analyzed if it was positive or negative, and they were all positive, which means they go upwards. Along this project, we can understand that comprehensive graphing is a method that helps us understand what is happening in a function by just looking at its graph, and it also helps us to understand all the points there are in it.